Hi, I'm Cameron Bahar, CTO of Huawei Storage. Thanks for taking the time to join us today as we discuss some of the most important features of all-flash arrays. Two prominent features of all-flash arrays are inline deduplication and compression. These features, when combined, help save space and reduce write amplification. So what makes these features so important to all-flash arrays? Storage systems, as you know, are quickly transitioning from using magnetic disks to flash media. The adoption of all-flash arrays in the market today continues to accelerate at a rapid pace. Although the raw performance of flash is quite high, the medium itself is limited by the amount of wear it can handle and take from rewrites. As a result, the amount of wear on flash needs to be carefully considered when designing all-flash SSD systems. Deduplication and compression solve both of these problems simultaneously. Deduplication reduces the number of writes and the volume of data being written. Compression, on the other hand, reduces the volume as well. Combined, these two technologies provide the best defense against wear while improving system-wide utilization and extending the service life of SSDs and therefore the entire system. There are two common approaches to deduplication in our industry. The first approach is called a strong hash. The strong hash uses SHA-1 or SHA-2 to fingerprint individual blocks. If the fingerprints on two blocks is a match, the system will consider the blocks to have identical content. Although the probability of conflict is low in strong hash algorithms, there is still a probability that it will produce collisions. Google, for example, has recently shown that there are issues with collisions using the SHA-1 algorithm. The second approach is called a weak hash. The weak hash, the deduplication using a weak hash approach makes use of a weak hash for fingerprints, but in addition performs a byte-by-byte comparison of the two data blocks in the unlikely event of a hit. The use of the weak hash algorithm along with the byte-by-byte comparison eliminates the possibility of returning incorrect data due to weak hash collisions. So the weak hash has an extra item which we call a byte compare. Okay? Huawei Dorado V3 products use this second technique to implement deduplication. So how does inline dedupe and compression actually work in the Dorado V3 system? Let's follow the path of an 8K write through the system as an example. When a block is first written, it's an 8K block, right? It's written to the cache. It's a persistent cache, right? And the write is immediately acknowledged. This allows the system to have low latency writes. When the data is stored in the cache and batched to a sufficient degree, then this data is flushed to what we call an SSD pool, which is a collection of SSD drives. It is on the path from the cache to the SSD pool that dedupe and compression take place. So there's several steps in this process. The first step is, for dedupe and compression, is that the fingerprint of each block is calculated using a weak hash algorithm. In the second step, global dedupe takes place, which ensures that data across all LUNs and controllers in the system is deduped. And in step 3, we actually do a hashing scheme to decide